Hi, my name is Doug Schneider. Welcome back to Real Hi-Fi, where I'm on location again, this time in Watsonville, California at MSB Technology. And I'm with one of its co-owners, Jonathan Gullman, who's the CEO, but also an expert in electronics design. And one of the things that affects hi-fi electronics is heat. And MSB goes to extreme measures to deal with heat in extreme ways. And we're going to learn what is important when it comes to heat. Jonathan, thank you for being here. Tell us about heat, and we'll use an amplifier as an example, as an extreme example of what can get hot and what is important to know about that.
Yes, so heat, or the thermal management of a product, there's really two aspects to it. The first aspect is absolute temperature. So the hotter any electronics in any industry run, the shorter the lifespan. So you obviously want to keep the product cool, because the cooler the product runs, the longer the life of the product. So if you see on our amplifiers, we have lots of heat sinks, and that's to dissipate the heat to keep the temperature down.
So overall, you want a cool running product, as cool as possible, and that will extend its life. Will it improve its performance, or?
No, that will extend its life. Now, what improves the performance is the temperature gradient across the devices.
Gradient, meaning?
The difference in temperature between the devices. So, as the temperature changes in electronics, the parameters and the analog parameters will change slightly, but it's linear among all of the devices. So, in the case of our amplifiers, we have heat pipes to spread the heat through the heat sink, but on our output modules here, there's all the output devices. And if you notice on the back, we have integrated heat pipes. The reason why we do heat pipes is they're very, very good at transferring heat from one point to another, much more effective than, a thick piece of copper, which will conduct the heat, but it won't be uniform temperature. And so what you want is you want all the devices to be at the same temperature, so they all have the same analog characteristics.
So uniform heat distribution.
Uniform heat distribution. You want all the devices to be at the same temperature, and then you want to keep them cooler. But the temperature gradient, or the difference in temperature between the devices, is more important than the absolute temperature.
Absolute temperature affects long life, or how long the life is, and gradient temperature, is that correct?
Yeah.
Affects the performance.
Correct.
And so when you're seeing these different pieces all put together, does that affect the temperature, the way heat transfers around it?
I mean, everything is, yes, there's going to be heat transfer between this. So all of our products are modular in design. It's mostly due to the manufacturing of it and reliability. But like specifically for our output module, this output module needs its devices at the same temperature.
Evenly.
But if this module and this module are different temperatures, that's not as important.
Okay.
Because this is a complete circuit, and this is a complete circuit.
So within the circuit, you want uniform distribution.
Exactly. Within the circuit, you want uniform distribution. Because again, it's not the absolute temperature of the circuit, it's the change in temperature across the circuit. So like our DAC modules are another example. They're all in metal cases. They all have a special material in it, and that's to keep all the resistors and all the analog devices at the same temperature.
And performing the same. Very informative. Thank you very much. I've never heard anyone talk about that, but I'm sure it is a huge topic people should know about.